Hello everyone, and welcome to another science video with me, Richard, and No Limits. So today's topic is all about dry ice. Now dry ice is frozen carbon dioxide. And now carbon dioxide obviously is what you breathe out. And you breathe in oxygen, but you breathe out carbon dioxide. Now you can take that carbon dioxide and freeze it. When you freeze it, we can do some amazing experiments with it. Now, we're going to talk about our old friends, the atoms, because they're really important with dry ice. And we're going to be talking about solid things, liquid things, and gas things. Because dry ice is a gas, the carbon dioxide, that's been frozen and turned into a solid. Now, normally, solids, when you melt them, they go from a solid to a liquid to a gas. So if you take like a piece of ice and you heat that piece of ice up, it turns into water. And if you heat that water up a little bit more, it turns into steam. So that is the solid form of water, the liquid form of water, and the gas. But dry ice is different because dry ice is frozen carbon dioxide and it's already a gas. But when you freeze dry ice, it goes straight to a solid with no liquid. And when you melt dry ice, it goes straight from a solid to a gas, from a solid to a gas with no liquid. So that has a very special name in science. When something changes from a solid to a gas, it's called sublimation. And that's what it is. The solid sublimes into a gas. To freeze dry ice, you have to keep it at minus 78.5 degrees Celsius. Now that's colder than the coldest day in the North Pole or the South Pole where the penguins or the polar bears live. The coldest day ever recorded there has never been as cold as how you have to keep dry ice. And because it's so cold, you can't pick it up with your hands. So you have to wear gloves, and especially like gardening gloves or builder's gloves, because they're insulated to protect your hands from the dry ice. And inside my box, there's another bag. And inside that bag is the dry ice. And the dry ice comes in great big chunks, just like that. And as you can see already, there's a little bit of steam coming off it. And that's because the dry ice is a solid and it's changing straight into a gas with no liquid stage in between. It's subliming. The process, sublimation. But it's really, really cold. But we can do amazing experiments with dry ice. Now one of the best ones that you can do is just to stick it in some water, because although it's melting in the air around us already, we can melt it quicker. And obviously the way you melt things quicker is to heat them up. So we're going to heat them up in our bowl of hot water just here. Add a bit more dry ice to see what happens. Fantastic! Now, can you hear all the bubbling? That's the dry ice melting in the hot water, and all of that steam coming out the side is the carbon dioxide being released into the air around us. Now, carbon dioxide is heavier than air itself. That's why it's coming out and spilling down and all onto the floor. And it's spilling out, as you can see, all around us, on the floor, and it will keep going until all the dry ice is used up, or all the water is used up. So obviously, if you want to go bigger, get a bigger bowl. More dry ice, put it all in. As long as you're using your gloves, and you're putting it in the water, it's nice and safe. So fantastic. dry ice bubbling away. So we're going to come back to our pot a little bit later. So, while it's bubbling away, we can do some other experiments with our dry ice. And what we have here is a little conical flask with a stopper in. And what we can do with that is you can play a few games with it. So if you take a little bit of dry ice, what you can do is you can pop the dry ice, one lump, into the water, and then you can play some games, like getting your stopper and popping it in your jar. Squeeze the stopper on really tightly. And then you can try and play cat with your friends, because if you're going to squeeze it on, one can see what happens. Oh, it's already trying to go! Hey, just like that! Where'd it go? So as that carbon dioxide is releasing, it's releasing all the gas into the air, so it's creating that big air pressure. Remember air pressure from a couple of weeks ago? It's creating pressure inside the jar, and it's making the pop up. Pop out! The stoppers are designed to go in the conical flask, and again, like always, I'll put links to everywhere where you can buy all these things. And now, obviously, we're coming out of lockdown and things are opening up more. It's a lot easier to get some of the more sciencey things like the conical flask. So, games with dry ice. Now, they also use dry ice and carbon dioxide, the gas that's in dry ice, in fizzy pop. And the reason they do that is because carbon dioxide dries your throat out. So as you're drinking your fizzy pop, your can of Pepsi or your Coke or your you're drinking it, okay, it's got lots of carbon dioxide gas in it. And as all that gas pops inside your throat, okay, it dries your throat out. And the experiment you can do about that is to take your piece of dry ice and put it in another special little conical flask with a bit coming out the side. So then what you can do, put it in, and if you just place your hand over the top, what you're going to do is you're going to get that dry ice and that steam, and you're going to do and taste it. Now when you taste it, it's going to taste a bit like fizzy pop without all the good flavours like the Coke or the Orangeade or the Limeade. Now it's perfectly safe to do it because it's just carbon dioxide gas, and just like you find in fizzy pop, you're never actually going to be quenched of your thirst, because it's designed to make you want to drink more and more and more, because it keeps drying your throat out all the time. Now, another experiment you can do with our dry ice is put a little bit of washing up liquid into a glass or a plastic beaker, and when you've done that, you can take your conical flask again, one with a little spout on the side, and you can attach a tubing to it, and again I'll put all the where you can buy all the things, I'll put all that in the resources for you to have a look at. So inside here we've got some just plain water and some washing up liquid, and inside our washing up, then what we're going to do is we're going to put our dry ice into our water in our jar, and then we're going to put the piping into the water, and we're going to see what happens. So let's get a bit more dry ice. Then we take our dry ice, we pop it in to our water so it sublimates out. we're going to create lots of gas. If you put your finger over the top, the gas is going to come out the tube instead. When you do that, and you put it into bubbly or washing up liquid in water, this is what happens. If you try and make the tube nice and wet, you should hopefully get a tube and it fills the gas and it drops to the floor. Make it nice and wet again. I'll come a little bit closer. So put it in there, make it nice and wet, get the gas inside, bring it out with a bubble. Pop. And again, it's all perfectly safe to play with because it's just carbon dioxide. Bubbling away and bubbling away and bubbling away. You can even make bigger bubbles and play games trying to get people to catch it. Whee! If you get it really wet and lots of fizzy, if you get it really wet and lots of carbon dioxide, sometimes you get more than one bubble come. And then you can make more than one bubble pop. Experiments with dry ice. Sublimation. From a solid straight to a gas. So we're going to go and get our bowl back again for the last little bit. Here we are with our bowl. Now stop bubbling away. We're going to add a little bit more water to it because some of it was used up in the experiment. And then we're going to add some more washing up liquid to it. So you saw what happened in the beaker with the washing up liquid. Now we're going to add the dry ice to the bowl with the washing up liquid, and then we're going to see what happens. So for this one, we need lots of dry ice. Lots and lots and lots. Make sure you do it in an area that you don't mind getting wet, because this is what's going to happen. And then when it comes out, you can take your gloves off and just play around with some of the bubbles. Pop them. Blow them. Put them on your head, on your hair, on your face. It's all perfectly safe. Just washing up liquid and carbon dioxide. It just keeps going. It keeps going. It keeps going. It keeps going. It keeps going. Dry ice. It's so much fun. Solid carbon dioxide. Minus 78.5 degrees Celsius. Colder than the coldest day ever in the North or the South Pole. There are more experiments I can do, so if you want to see any more experiments, let me know on the emails and I'll do some more experiments for you with dry ice. It's so much fun. Thanks for watching. Bye.